In this section we will talk about inverse function. Okay, so in our previous section we talk about function. Now let's go back. So let's consider we have a set A here, we have a set B, and there is a function defined from set A to set B. Okay, set A has an element like -2, 0, 3. Set B has an elements like 5, 1, 2. So -2 corresponds with +5, 0 corresponds with 1, 3 corresponds with 2. Now this is a mapping diagram. Okay, this is how we use our mapping diagram to represent a function. Now this is a function, right? Because every element from first set has exactly one element in a second set. So this is a function. Now what do we call every element, or what do we call a set of every element from set A? What do we call collection of every element from set A? We call input or domain, right? And so we use X, right? So every element is an input or domain, and in general we use X to represent this, right? In the similar way, every element from set B we call output or range. Okay, now let's define a new function, and in a new function we will switch elements, our input and output. Okay, so let's define a new function. So we take a set B here, we take a set A here. So set B has 5, 1, 2, set A -2, 0, 3. 5 corresponds with -2, 1 corresponds with 0, 2 corresponds with 3. Now at first, is this a function or not? Okay, this is a function. Okay, so this is a function. Every element from set B has exactly one element in a set A. Now in this case, what are input and or a domain? So what element will be an input or a domain for this case? So which one is input or which one is domain? Every element of a first set is always input. Okay, so this is our input. Every element from set B is an input. Every element from set A is a output. Now, so here we have a function f. Okay, function f has these numbers as an input, 5, 1, 2 as a output. Now what we did, we switch our input as an output. Okay, so we have -2, 0, 3 as an output here, and we have 5, 1, 2 as an input for this new function. Okay, and we call this new function as a f inverse function. So this is f inverse function. Okay, so this is f inverse function. So if we switch domain and a range, okay, after switching domain and range we get a new function, and that new function will be the inverse of the function. Okay, and this is not f to the power 1. Okay, this is f inverse. Okay, similarly if we have a function g, then its inverse is g inverse. Okay, so if we have a function h, then its inverse is h inverse. Okay, so to find the inverse of a function, we are switching the input and the output. Okay, you switch x and y, you get the inverse of a function. So let's take a straight line. Okay, so any straight line has a 2 points. Okay, let's draw a straight line here. Okay, so this is let's say this is 0, 3, and this is 4 0. So this is a straight line. Okay, and straight line is a function. Now in order to find the inverse of this straight line, we are switching our x coordinates and y coordinates. Okay, so we have a 0 3 point. Now let's switch x and y coordinate. So what do we get? We get a new point. So you are taking 3 as a x coordinate and 0 as a y coordinate. So we have a 3 0. So next point we have a 4 0, and its inverse is you are switching x coordinate to y coordinate and y coordinate to x coordinate. So we will have 0 4. Okay, now let's plot these 2 points. So we have a 3 0. So 3 0 is here. Okay, 0 4 is here. And we get this graph, and this will be the inverse of the first line. Okay, so finding the inverse means you are switching x and y. Okay, you switch the input and output, we get the inverse of a function. Okay, any question up to here? So finding the inverse means we are switching x coordinate and y coordinate, or we are switching domain and a range. Okay, if we switch a domain and range and get a new function, that new function will be an inverse of the original function. Okay, okay, now here we have an example. So we have a two function, f of x, we have a g of x function, and we are asked to verify that these two functions are inverse of each other. So we have a two different function. Again, we want to check whether these two functions are inverse of each other or not. It means the inverse of function f is g of x, and the inverse of g of x is f of x. That's what we need to prove. Okay, now if for that we find the composite of these two functions. Okay, in order to show these two functions are inverse of each other, we need to find f composite g of x. Okay, and we need to find g composite f of x. So we have a two different function. Okay, we have a f function, we have a g function, and we want to show these two functions are inverse of each other. Okay, and for that we find composite of these two functions. So at first we find f composite g and we find g composite f. Now how do we find f composite g? So what is the definition for f composite g? This is f of, you just replace composite by parenthesis, of g of x. This is the definition. Now we do a substitution here. So we know what is g of x. So let's go ahead and substitute for g of x. F as it is. G of x is x over 3 plus 4 over 3. Okay. Now, how do we find f of this expression? How do we find? So here we have a f function, right? So we are using f function, and we replace every x of a f function by whatever expression we have in the parentheses. Okay, since you have a f function here, so we are taking f function and you replace the every x of a f function by this expression. So in the f function we have 3 times x, and for that x we write down x over 3 plus 4 over 3. We have more than one term, make sure parenthesis, then negative 4. Okay, you are replacing every x of a f function by this expression. Now let's simplify. So let's distribute 3 to both of these terms here. So 3 times x over 3. So we have 3 times x over 3 plus 3 times 4 over 3 minus 4 So this 3 cancel, this 3 cancel. We have x plus 4 minus 4, and we have x. Okay, so our F composite G is x. So now in the similar way, can you find G composite F? How do we find G composite X? At first we need a definition. So what will be our definition for this G composite X? It will be G of F of X. Okay, replacing composite sign by parenthesis, we get the definition. So what would be our next step? So we know what is f of x, right? So we replace our f of x. And what is f of x equals to? F of x equals to 3x minus 4. So we replace our f of x by 3x minus 4. So we have g as it is. And for this f of x, we write down 3x minus 4. Now we need to find g of 3x minus 4. So how do we find g of 3x minus 4? For that, we take, which function do we take? We take a g function, okay? And from g function, we replace every x of a g function by this expression 3x minus 4, okay? We write down g function, which is x over 3. For that x, we write down 3x minus 4 divided by 3, then we have plus 4 over 3. Okay, now we can break this down. We can rewrite this as a 3x over 3, and we have a negative 4 over 3 plus 4 over 3. Okay, we can always rewrite, separate this as a two different fraction. Okay, they have a both common denominator. Now negative 4 over 3, positive 4 over 3, this is 0, and positive 3x divided by 3 is x, and this is our G composite F. G composite of F is x. Now what common do we see in these two here? Here F composite G is also x, G composite F is also x. And if this is the case, okay, so if G composite F is equals to F composite G and this is equals to x, then our F and G are inverse of each other, are inverse of each other. So the inverse of function F is G and the inverse of function G is F. Okay, so here we are given two different functions and we want to check whether those two functions are inverse of each other or not. For that, we find the composite. Okay, we find F composite G, we find G composite F, and if both composite are exactly x, then these two are inverse of each other. Any question? Is anyone still writing? Are you done? F and G are inverse of each other. Okay, now this can be, now we can just define this in, okay, now here we have a definition here. So we have a function f, right? And the inverse of this function f is f inverse. So this is f inverse. So here, so we have f inverse of f of x is equals to x, okay? And f of f inverse x is x. So here, this is f composite, sorry, at first we have F inverse. So this is F inverse composite F, and this part is F composite F inverse. Okay, so in our case we have F inverse as a G, so they use a G here. Okay, so G composite F and F composite G, if that is equals to X, then our two functions are inverse of each other. Okay, it's the same thing here. Okay, now we will learn how to find the inverse of a function. Okay, so here we have a 5 steps. The very first step of finding a inverse of a function is, so we start the expression for a given function f. Okay, now let me take an example and we'll follow each step. Okay, so let me take the same function f of x equals to 3x minus 4. Okay, so let's take, we have a function f of x equals to 3x minus 4, and we want to find its inverse. Okay, now the very first step is that we replace our f of x by y. Okay, so we replace, that is our first step, replace f of x by y. If you have g of x, you are replacing g of x by y. Okay, if you have h of x, we are replacing f of x, g of x by y. So we have y equals to 3x minus 4. Okay, this is the first step. Next, we interchange x and y, or we switch x and y. Okay, switching x and y give us the inverse function. Okay, so for every x we will write down y, for every y we will write down x. So here we have y, now we are rewriting, we replace this y by x equals to, we have 3 as it is, and for this x we write down y minus 4. Okay, we switch our x and y as our second step. Third step, now we solve this equation for y. So we solve for y. Okay, solving for y means we have to make y by itself in one side. So let me write down this equation. So we have x equals to 3y minus 4. We are solving for y, it means we need to get rid of negative 4, we need to get rid of 3. How do we get rid of negative 4? We add 4 on both sides. So we have x plus 4 equals to 3y. Now we need to get rid of 3, and for that we divide each term by 3. So we have x over 3 plus 4 over 3 equals to y. Okay, the last step is that we replace our y by, so the last step we replace y by f inverse x. Okay, so we have x over 3, so our inverse function is x over 3 plus 4 over 3 equals to f inverse x. So f inverse x is x over 3 plus 4 over 3. So in our previous example, what they call this function x over 3 plus 4 over 3, they called g of x, right? Okay, so first step, you replace your f of x by y, right? You replace f of x by y. Second step, you switch x and y. Okay, for every y you are writing x, for every x you are writing y. The remaining, everything remains same. Okay, sign, coefficient, power, everything remains same. Next, you are solving for y. You make y by itself. Okay, and that y is the inverse function. Okay, let's do one more function. Okay, let's find the inverse of one more function. Okay, here, so let me take this example. Okay, so here we have this function f of t equals to, so we have f of t equals to negative 3t plus 1, negative 3t plus 1. Okay, so this is a function here. For this function, what do we have as an input? We have an input t, right? And you can rewrite this function with, rewrite this function with an input x. Okay, like if you wanna have x as an input, you can rewrite this as a f of x. You replace every t by x. We have negative 3x plus 1. These two are exactly same function. Okay, these two are not different. You can always rewrite. Okay, so in general we use x for our input and f of x for our output. So in this case we have a t as an input. Okay, you can rewrite this function with x every time. Okay, if you have confusion, then you can always rewrite using x. Now let's find the inverse of this f function. So what is the first step? We replace this f of x by y. So we have y, okay, equals to negative 3x plus 1. So this is our first step, replacing f of x by y. What is the second step? We switch x and y. So for every y, we write down x. For every x, we write down y. So we have negative 3, we write down y plus 1. Okay, you are switching x and y. Next, we solve this equation for y. So we make y by itself. For that, we subtract 1 on both sides. So we have x minus 1 equals to negative 3y. Now we divide each term by negative 3. So x divided by negative 3, that is negative x over 3. Negative 1 divided by negative 3, that is positive 1 over 3, equals to y. At the end, you replace y by f inverse. Okay, so we have negative x over 3 plus 1 over 3 equals to f inverse x. And this is the inverse of our function f. Okay, you won't have these steps on your exam. Okay, you have to practice. You replace f of x by y, you switch x and y, you solve for y, and that is your inverse function. Okay, any question up to here? Okay, now let's go ahead and see what we have next. Okay, so here, now let's take a mapping diagram. Okay, let's take a function. Let's say we have a f function. Okay, we have a 1, 2, 3. We have a 4 here. So 1 corresponds with 4, 2 also corresponds with 4, 3 also corresponds with 4. Now, is this a function or not? Is this mapping diagram a function? Is it a function or not? To be a function, every element from first set must have exactly one element in the second set. Now, does this example satisfy the definition? Why this is not a function? So to be a function, every element from first set must have exactly one element in the second set. So do we have every element from first set corresponding exactly one element in a second set? Yes, right? So 1 corresponds with exactly one element 4. 2 corresponds with exactly one element 4. 3 corresponds exactly one element 4. So it means this is a function. Okay, they can correspond to same element. Okay, but every element must have exactly one element. That's the definition. Okay, now if we switch our input and output for this function, what happens? So we write down 4 in our first set. In the second set we have 1, 2, 3. So 4 is corresponding to 1, 3, 4 is corresponding to 4 is corresponding to 3. Now, is that a function or not? Why that is not a function? Because 4 corresponds more than one element. It corresponds to 3 different elements. So this is not a function. Okay. So this is not a function. Okay. Now we have a function f. Okay. We switch our input and output. And after switching input and output, this function, new function we get is not a function. Okay. Now what does it mean here? It means that every function, they do not have an inverse function. Okay, like in our very first example, so here we had this function f, we switch our input and output, and after switching input and output, this is a function, so our inverse is a function here. Okay, in this example we started with a function, our f is a function, but when we switch our domain and input, we have no more function. It means this function does not have an inverse function. Okay, so every function, they does not have an inverse. So to have an inverse function, we must have one specific type of function, and we call that one-to-one function. Now what does it mean by one-to-one function? So let me take set A, okay, let me take set B. So we have elements like -4, 1, 2, we have 0, 4, 5. Now to be a one-to-one function, if every element from first set has a unique element in set B, then it is a one-to-one function. Okay, so -4 corresponds to exactly one element is 0, 1 corresponds with 4, 2 corresponds with 5. Now here, every element from set A has a unique element in set B. Okay, so none of the 2 or more elements has same output. Okay, every input has its own unique output. If that is the case, then our function is one-to-one function. Okay, so to be a one-to-one, every input must have its own unique output. Okay, now let me take a function which is not one-to-one, like the one that we had earlier. So 1, 2, 3, we have a 4. Now we know that is a function, right? So this is a function. Every element from first set has exactly one element in second set. This is a function, but this function is not one-to-one. And why is that? Because they do not have a unique output. They have same output. 1 also has output 4, 2 has output 4, 3 has output 4. Okay, their output is not unique. Okay, but here this element, this input has a unique output here. So, okay, so it means our first mapping diagram, this is a one-to-one function, and this is not a one-to-one function, but this is a function, it is not a one-to-one function. Okay, now if we have a function, and if that function is one-to-one function, then those function has its inverse. Okay, every one-to-one function has an inverse function. If our function is not one-to-one, then the function does not have its inverse. Okay, so to have an inverse of a function, our function has to be one-to-one. Okay, to be one-to-one means every input of a function must have its unique output. Okay, and if every input of a function has unique output, then we call that function one-to-one function. Okay, so let me take one more example here, then we'll start. Okay, so A, 1, 2. So B1 corresponds to 1, B corresponds to 2, C corresponds to 2. Now at first, is this a function or not? The third mapping, is that a function? So to be a function, what we need? Every element from first set must have one element in the second set. So A has only one element, B also has only one element 2, C also has exactly one element 2. Okay, so this is a function. Now is this one-to-one function? So to be a one-to-one function, every input must have its own unique output. Okay, so here B and C, they both have a same output. So this is not a unique, and because of this is a function, but this is not a one-to-one function. And since this is not one-to-one function, its inverse does not exist. Okay, only if our function is one-to-one, then its inverse exists. If our function is not one-to-one, the inverse does not exist. Okay, now how do we show a function is one-to-one or not? So let's take an example. So let me take the same function that we had earlier, f of x equals to, okay, so we had, is it 3x minus, okay, 3x minus 4. 3x minus 4. Okay, we did calculate inverse of this function, okay, in our previous example. Now how do we know whether this function is one-to-one or not? Okay, that's the question here. For that, okay, we pick two inputs. Okay, let's call, we have a two different input, and you can call anything. Okay, so let me call A, B. So we have a two different inputs, A, B. Now we assume that the output for both of these input is exactly same. That's our assumption. Okay, so how do we write down the output for our input A? So if we have an input A, what will be output? Our output will be f of A, right? So we have f of A as the output for A, and f of B is the output for B. Okay, and we assume that these two output are exactly same. Okay, like if in a mapping diagram, so we have a input A, we have a input B here. Okay, and we have a output f of A, and we have a f of B. And f of B, A and f of B, they are equals to each other. They are same. That's our assumption. Okay, so we have a two different input A and input B. These are two different at first, but the output for output of A, which is f of A, and output of B, which is f of B, but these two are exactly same thing. That's our assumption, but we are not sure. Okay, now if this is the case, now what will be f of A? How do we find f of A? So what will be f of A? Our function f is 3x minus 4. So what will be f of A? How do we find f of A? We replace x of a function f by A. Okay, so that is 3 times A. 3, so you replace every x of a function f by this input A. So 3 times A minus 4 equals to, now what will be f of B? What will be f of B? It's the same thing, right? You take a function f, replace every x by B. So 3 times B minus 4. So we add 4 here. So this is 0, this is 0. So we have 3A equals to 3B. Now let's divide both sides by 3. So what do we get? A is equals to B. How did we start? We started that our A and B are a different input. Okay, so here we started that our A and our B, these are two different input. Okay, and for but their outputs are exactly same. That's our assumption. Now when we assume their outputs are same, what we get? We found those inputs are also same, right? So we found that A is equals to B. Okay, so we started with a two different input. A and B are two different number, but our assumption is their output is exactly same. And when we simplify, when we solve this assumption, we end up getting our input equals to each other. But we had these A and B as a different number in the very beginning. Okay, after assuming their output is exactly same, we have input same. It means that we have, okay, so here, so at first A has output f of A, B has output f of B, right? These two are same. At the end, A and B is equals to means we have a one line. So it means this function is one-to-one function. Okay, so f is one-to-one function. And this is how we show our function is one-to-one or not. Okay, so let's take one more example. Okay, so here we have a function f of x equals to negative 3x plus 8. This is a function and we want to know whether this function is one-to-one or not. For that, we take two different input. Okay, let's call, we have a and B as a two different input. Okay, we assume f of A is equals to f of B. It means the output for A is f of A, the output for B is f of B, and we assume that these outputs are equals to each other. Now we solve, so we find f of A. F of A is, we replace x by A, so we have negative 3a plus 8 equals to, now we find f of B. You replace x by B, so we have negative 3b plus 8. Now we have positive 8 on both sides, so let's subtract 8 on both sides. This is 0, this is 0. So we have negative 3a equals to negative 3b. Now let's get rid of negative 3 on both sides. And we have A equals to B. Okay, we started with A and B being a two different number, but after assuming their outputs are same, we have that our input A and B are also same. It means our function f is one-to-one function. So this is how we can show whether a function is one-to-one or not. And you will have one question, okay, where you will be asked to show a function is one-to-one or not. Now this is the algebraical method, okay. Now we can also show a function is one-to-one or not using a graphical method. Now here, the next here, we have to check whether this graph is a one-to-one or not. Now at first, is this graph a function or not? Yes. And what test do we use? We use a vertical line test, right? So if any vertical line crosses the graph exactly at one point, then the graph is function. Okay. So wherever you draw vertical line, it does not matter. It always crosses exactly at one point. If this is the case, our graph is a function. Now to check for one-to-one, we use horizontal line test. Okay, so we draw a horizontal line here. Okay, let's draw a horizontal line. Okay, if every horizontal line crosses the graph more than one point, then the graph is not one-to-one function. Okay, if every horizontal line crosses the graph exactly at one point, then our graph is a one-to-one function. Now here, so So this horizontal line crosses at one point here, but this horizontal line crosses the graph at three different points. This horizontal line crosses the graph at three different points. This horizontal line crosses the graph at one point. Okay, but what we want every horizontal line to cross the graph exactly at one point to be a one-to-one function. Now, is this graph one-to-one function? This is not a one-to-one function. And if this is not one-to-one function, does it have an inverse function? Can we find a inverse graph for this graph? No. Okay, to have an inverse function, the function has to be one-to-one. Since this is not one-to-one, this graph does not have an inverse function. Okay, so to check whether a graph is function or not, we use vertical line. If vertical line crosses exactly one point, the graph is a function. Okay, if for the one-to-one function, we use horizontal line test. Okay, and every horizontal line test must cross exactly one point. Okay, not one, every horizontal line. Okay, and we already showed this function this function is one-to-one and it has an inverse, and so this is the inverse that we did here. Okay, now here we have a two function, f of x equals to negative 2x plus 3, and we know its function is this one. We are asked to graph this function. Okay, let's go ahead and graph. We are asked to graph in a same scale here. So this is x-axis, this is y-axis, we have origin. Now, how do we graph this function? So what is the y-intercept for this function? This constant is y-intercept, right? So 3 is the y-intercept. So this is 3. So let's start here. Our slope is negative 2. Now what does it mean? 1, 2, 3. So slope is negative 2 means you go 1 unit right and go down by 2 unit. Okay. So 1 unit right, 2 unit down. So this is our second point. So we have this graph. So this is a graph for our f function. So this is our f of x. Now let's graph f inverse x. So let's graph this one. Our x-intercept is 3 over 2, which is 1.5, right? So 1.5 is here. So this is our y-intercept. What is the slope? Slope is negative 1/2. Now what does it mean? Negative 1/2. So how do we find a second point? So you run denominator. Okay, you go 2 unit right and go down by 1 unit. Okay, so negative is negative 1 divided by 2. So you go 2 unit right, 1, 2 unit right, then go 1 unit down. 1 unit down means 0.5. So this is our second point. So this is our f inverse x. Okay. Okay. Any question up to here?